This is a question from sequences and series. So we have a sequence here, A1, A2, A3, and so on and so forth, that's defined by the A sub n is equals to 3n squared. This is the nth term of this sequence. And it mentions that the difference between successive terms of the sequence forms a new sequence B1, B2, B3, and so on and so forth. So part A express B sub n, okay, the nth term for the sequence with B in terms of n. Okay, and B show that this sequence B1, B2, B3, and so on and so forth is an arithmetic sequence, and state its first term and common difference. C, find the sum of the first n terms of the sequence B1, B2, B3 in terms of A sub n and B sub n. So let's say for the first part, we look at part A here. How do we express B sub n in terms of n? So when we write down this sequence, okay, we have A sub 1, A sub 2, A sub 3, okay, and so on and so forth. So they're saying that the difference between each successive terms forms a new sequence. So this would be B1, the difference between, so B1 would be the difference between A sub 2 minus A sub 1. And then between A sub 2 to A sub 3, that will be B2. Okay, so B sub 2 would be A sub 3 minus A sub 2. And of course, B sub 3, okay, would lead to A sub 4, and so on and so forth. So if we continue in this pattern, so B sub 3 would be A sub 4 minus A sub 3. And what would B sub n be? If you continue to go it down this way, so B sub n would be equals to A sub n plus 1 minus A sub n. See the pattern here? 1, 1, 2 and 2, 3 and 3, so n, right? And then if this is 1, and then the next number here is 2, which is 1, the difference is 1, so 2 plus, and then plus 1 will be 3, 3, and then plus 1 will be 4. So n, this will be n plus 1. Okay, so that's how we get it, the relationship between of B sub n in terms of A. And then now we need to figure out what is A sub n plus 1, because it's given here that A sub n is 3n squared. Okay, so in this case, if A sub n is 3n squared, so A sub n plus 1 has to be 3 multiplied by n plus 1 squared. So we just change the n, okay, we just change this n here from an to n plus 1. Okay, so this becomes 3 times n plus 1 squared. Right, so this is just a note here. Now, we minus 3n squared, we expand the bracket, so this is n squared plus 2n plus 1 minus 3n squared. If you expand the bracket, so here 3n squared plus 6n plus 3 minus 3n squared. So we can cancel off 3n squared here. So that leaves us with just 6n plus 3. Okay, so that answers the first part. B sub n is equals to 6n plus 3. That is B sub n in terms of n. That's the first part. Now let's look at the next part, part B. So how do we show that this sequence of B's is an arithmetic sequence? What is the first term and what is the common difference? Right, so let's start with that. So from this B sub n term that we obtain, okay, from this B sub n equals to 6n plus 3, if I try to write down the terms in this sequence B, so B sub 1, the first term will be 6 times 1 plus 3, which is 9, so this is the first term. The second term would be 6 times 2 plus 3, that would be 15. The third term will be 6 times 3 plus 3, which is 21. Okay, so in this case, how do we show that it is an arithmetic sequence? So we'll have to calculate, okay, what is B2 minus B1? That is 15 minus 9, which is 6. B3 minus B2, third term minus the first term, that's 21 minus 15, that's also 6. Okay, so if you continue to do it this way, we can show that this every successive terms here, okay, have the same difference. So B2 minus B1 is equals to B3 minus B2, and so on and so forth. So therefore, okay, B1, B2, B3, okay, and so on and so forth is an arithmetic sequence. Okay, because it has a constant common difference. So what is the first term here to answer the question? So the first term is equals to 9. Okay, that is B sub 1. Okay, and the common difference is equals to 6. Okay, so that answers part B. Now, last question here, part C. Find the sum of the first n terms of the sequence B1, B2, B3 in terms of A sub n and B sub n. Right, so let's complete that part. So in part C, so for an arithmetic sequence, which we have just, for this sequence B1, B2, B3, since we've showed that it's an arithmetic sequence, so the sum of the first n terms is equals to n over 2 multiplied by 2 times A. A would be the first term, okay, plus n minus 1 times D, D being the common difference. This A here has nothing to do with the sequence of A from the question, okay, it's a A representing the first term. Okay, you can pick other notations if you want, but from this sequence of B1, B2, B3, okay, the first term is equals to 9. Okay, so we can substitute the numbers in here, so 2 times 9 plus n minus 1, and the common difference is 6. Okay, so we have 2 times 9, 18. 18 divided by 2, that would be 9. And then here, 6 divided by 2, that would be 3. So that would be 3n minus 3. If you simplify further, that would be 3n plus 6. So this would be 3n squared plus 6n. Now, we are not done yet because we still need to express this in terms of A sub n and B sub n. A sub n is 3n squared. Okay, so it's just nice. Okay, so it's just right that this first part here, you can substitute this into A sub n. Okay, so because A sub n is equals to 3n squared. So we can do a direct substitution. But what about 6n? Now, from our previous question, part A, we found out that B sub n is equals to 6n plus 3. So 6n, okay, so in this case, 6n is equals to B sub n minus 3. Okay, so 6 sub n, we can substitute it into B sub n minus 3. Great, so that completes the question for part C.